Hi, today our group will be presenting about conventional saw cutting versus wire EDM cutting. This presentation will be presented by Muhammad Hadif, Akmal Hazik, Ahmad Faik, and Miranda Quinton. Conventional saw cutting is a mechanical cutting process that uses a serrated blade to cut materials. In simple terms, a saw's teeth chip away small bits of the material with each movement, creating a narrow cut called a curve. This method has been used for centuries in woodworking and metalworking, making it a traditional, widely understood technique. Whether using a handheld hacksaw or a powered bandsaw, the principle is the same. The saw's teeth gradually remove material and separate the workpiece along the desired line. Because it relies on direct contact and force, no special technology or heat is required, just the saw blade and the material. This straightforward approach makes conventional saw cutting an accessible entry point for cutting a variety of materials. Moving on to the main capabilities of conventional saw cutting. One of the key strengths of conventional saw cutting is how many types of materials it can handle. With the right blade, we can put everything from softwoods like pine to harder materials like steel or aluminum, and even non-traditional materials like plastic, rubber, or leather. For example, in construction, it is common to use saws to cut both wooden framing and steel rebar on the same site. The conventional saw cutting method isn't limited to straight lines. While circular saws while circular saws are great for straight cuts, tools like jigsaws and scroll saws allow us to follow curves, angles, or detailed outlines. That's why saw cutting is often used in furniture making and signage, where decorative or irregular shapes are needed. Another big advantage is its ability to handle different sizes and thicknesses. Saws can slice thin sheet metal or plastic panels, but they can also handle thick materials like 2x4 lumber, steel rods, or PVC pipes. In industrial settings, bandsaws are commonly used to cut through large steel blocks before machining. Compared to other methods, saw cutting is relatively fast. Whether you're trimming wood for a frame or cutting metal to length, saws allow for quick material removal. This makes them ideal for workshops and construction sites where speed and productivity are important. For example, using a chop saw, workers can cut dozens of metal tubes in minutes.
So there are many advantages for conventional saw cutting. So number one is fast and efficient. One of the biggest advantages of saw cutting is its speed. It allows for quick material removal with very little setup. This makes it ideal for high-speed production environments or even simple everyday cuts where time matters. Number two, low equipment and operating costs. Another key benefit is cost. Compared to more advanced cutting technologies, saws are relatively cheap to buy and maintain. Even the blades are affordable and the energy they use is minimal, which keeps operating costs low. Number three, easy to learn and use. Saw cutting is also very beginner friendly. Most people can learn how to use a saw safely and effectively with just some basic training. Unlike CNC or laser systems, you don't need to learn software or programming to get started. Number four, highly versatile. This method is highly adaptable. With the right blade, you can cut through wood, metals, or even plastics. Some saws are designed for straight cuts, while others, like jigsaws or bandsaws, can handle curves and shapes as well. Number five, portable and accessible. Finally, many saws are compact and mobile, which means you can bring them directly to a construction site or work area. This makes and this makes on-site cutting super convenient and eliminates the need for large fixed equipment. Okay, now I I'd like to I'd like to discuss the main disadvantages of conventional saw cutting. First, lower precision is a major issue. Conventional sawing isn't as accurate as some modern cutting methods, so it's not ideal for making very intricate patterns or detailed shapes. Second, there is problem of blade wear. Over time, the saw blades can become dull or even break, especially when cutting harder materials. This means you have to replace blades fairly often, which adds to the overall cost. Another important point is noise and dust. Sewing operations create a lot of noise, generate heat, and release small particles into the air. This can be a health and safety concern and may require additional ventilation or personal protective equipment for workers. There is also the issue of manual labor. If the saw isn't automated, the quality of the cut can really depend on the operator. Fatigue or inconsistency can result in poor cut quality, which is a significant drawback in high volume or precision work. Let's take a quick look at the cost side. The initial cost for a saw can range widely, anywhere from $50 to $3,000, depending on the type and quality of the saw. Operating costs are relatively low per cut, typically just a fraction of a cent to a cent. However, maintenance costs can add up from $100 to $500 annually, and as I mentioned before, blade replacement is another factor, costing anywhere from $10 to $200 per blade. So, while conventional saw cutting is a try and true method, it definitely comes with some limitations and ongoing costs that should be considered before choosing it for your cutting needs.
Now let's look into the EDM wire cutting. What is EDM wire cutting? EDM wire cutting stands for electrical discharge machining. It is a process that involves using a thin wire to cut through metal parts. This wire doesn't touch the material. Instead, it removes it using electrical discharge. This sparks occurs between the wire and the workpiece, precisely melting and eroding the metal. It is considered a modernized method. Why? Because it is extremely precise and especially useful for cutting complex shapes. It works really well on hard materials and is perfect for parts that are too delicate or thin for the traditional cutting methods. Some common examples include die and mold manufacturing, as well as creating tiny, intricate structures in aerospace or medical device. As shown in the diagram, the ionized water is used to cool and flush away material, and the wire continuously feeds through the machine, ensuring a clean and accurate cut every time. So, EDM wire cutting is all about precision. It is a high technology method that brings quality and accuracy to modern manufacturing. Now let's look at the capabilities of EDM wire cutting. First, it can cut extremely hard materials. It is powerful enough to cut through tungsten carbide, one of the hardest materials known. It can also handle hardened tool steels, aluminum, and any conductive material. Second, it creates a highly detailed and complex shape. Wire EDM is precise enough to cut designs like an eagle shape, fine text, or even logos directly out of metal. Third, it can cut from the center of a part. By using a small hole drilling, a starter hole is drilled first, so the wire can be threaded through. This action lets EDM wire cutting begin to cut from the inside of a solid workpiece. Fourth, it produces a high surface finish. By using multiple skim cuts, EDM can leave parts with a very smooth and polished finish. This minimize the need for additional surface treatments. And lastly, EDM wire cutting allows taper cutting. What is taper cutting? Taper cutting means it can create angle or slanted features where the top and the bottom profiles of the cut are different. The wire guides can move independently, allowing complex tapers and shapes can be done. Thus, EDM wire cutting is not just accurate, it is also incredibly versatile and perfect for demanding high precision application. Now let's explore the advantages of EDM wire cutting. First, EDM wire cutting can create complex shapes. Wire EDM is capable of producing very intricate design, fine contours, and even tiny holes, especially in the hard or fragile materials. Second, it involves no mechanical force or deformation while cutting it. Instead of using physical contact, EDM cuts with sparks. This already eliminates any pressure, distortion, or stress on the part during the cutting process. Third, it offers high tolerance capability. Wire EDM can achieve tolerance as tight as plus or minus 0.0005 inch, and sometimes even down to a few microns, making it very ideal for industries that demand extreme precision. Fourth, it requires minimal fixturing. Compared to traditional machining, EDM setups are simpler and faster. It doesn't need complex or bulky fixtures, which already save both time and effort while cutting. Fifth, it delivers a very high accuracy. The cuts are extremely precise, and in most cases, no further machining is needed to finish the part. So overall, I can say EDM wire cutting brings powerful benefits from accuracy and precision to the ability to cut even the most challenging shapes with ease.
There are some disadvantages of EDM wire cutting as well. First of all, EDM wire cutting is only compatible with materials that conduct electricity. These are materials like aluminum or other metals, and this is because of the electricity that it uses when cutting the material. The second disadvantage is the oxide layer that sometimes develops on the cut surface of some materials. This sometimes occurs, but again depends on the material that is being cut. The third disadvantage of EDM wire cutting is the cost. This is a very expensive machine initially, and it is also very expensive to maintain. It's very accurate, so this will pay off in the long run, but it is a bit of a disadvantage overall. The fourth disadvantage is the slow machining speed that the machine has. This is especially the case for thick materials, so you must make sure that you take this into account when you are cutting thick materials versus thin materials. The final disadvantage for EDM wire cutting is the finish that it creates on the material. It often creates a rough finish, which causes you to need to have another machine to finish the cut smoothly, whether that be sanding or any other method. Now let's get into the cost. The initial cost is between $100,000 to $500,000, while the operating cost it varies a lot, but it's generally around a cent per millimeter. The maintenance cost is generally between $3,000 and $5,000, and this machine also requires dielectric fluids, which cost between $1,000 and $2,000 to replace. Now let's get into the applications of wire EDM cutting versus conventional cutting. Conventional saw cutting is generally used in an industrial manufacturing facility to perform fast, rough cuts before precision machining steps. For example, in construction sites, conventional saw cutting is used to cut metal pipes, steel bars, and wood beams to size on sites. On the other hand, EDM wire cutting is a more precise method of cutting and is most commonly used in mold and die manufacturing. For example, it can be used for a medical injection mold tool. Wire EDM is used to cut channels and tiny features with no post-processing required to produce high-quality molds for the plastic parts.
Now, moving on to the manufacturing readiness level, or MRL, of EDM wire cutting. MRL is a scale from 1 to 10 that measures how ready a manufacturing process is for production. Levels 1 to 3 cover the earliest stages, basic research, concept development, and initial proof of concept. At these stages, the process exists mostly as a theoretical idea or a lab experiment. EDM wire cutting is far beyond that. It is a mature, production ready technology, typically rated at MRL 8 to 10. That means it's been demonstrated on a production line, supports full rate manufacturing, and follows lean practices. It is widely used in industries like aerospace, automotive, and medical for cutting hard metals with precision. However, if EDM is applied to new or experimental contexts like cutting next gen materials or integrating with additive manufacturing, it might drop to MRL 4 to 7 depending on how developed and tested those adaptations are. So, in summary, for standard use, while EDM is a high MRL process, but like any technology, its readiness can vary when applied in new ways.
Now, let's take a look at the resource bias in our research. First, one of our resources came from a company that makes EDM wire cutting machine. Since they have a stake in the technology, they may focus more on the positive and make wire EDM sounds better than it really is. Next, we notice that company materials often highlight the good parts and leave out the downsides, like any challenges or limits of EDM wire cutting. To balance that, we also use information from independent machining websites. These sources doesn't have a reason to promote one technology over another, so their content is usually more fair and balanced. By using both kinds of resource and being aware of bias, we were able to get a more complete and honest picture of EDM wire cutting. And that concludes our whole research. Thank you.